Okay, so when we got to 9C, something really weird happened. You are asked to find where these two things intersect. What points do these two things have in common? And I've sketched my graph, I have that line, and let's just sketch in the line y equals 9. Well, I kind of want to know whereabouts that would be. So if I think about this as 5, 2, and my radius is 6, being the square root of 36, that means that this line here, our radius, is going to be 6 more units above its current height of 2. So this point will be at 8. Oh, well that's not very convenient because I want to know where the circle intersects with y equals 9. And if this has its highest point at 8 and y equals 9 is here, you can see that these two things, they share no points in common. In fact, that's the answer, and you could stop right here, realizing that the line that you sketch in for y equals 9 will never intersect with the circle. So the answer is no solution. But the thing is, some of us don't sketch things, and we don't always slow down to think about the question. But don't worry, algebra will have your back if that's the case, because even algebraically, you won't be able to find a solution. And let's just look at what is going to happen and why this won't work according to algebra too. So just like before, I'm going to substitute y equals 9 in for my y value. That's going to give me the equation x minus 5 squared is equal to, plus my 9, my y value, minus 2 squared is equal to 36. Here I can simplify this. 9 minus 2 is 8, and 8 squared is 64. Now I'm going to subtract that 64 from both sides. And what this is going to give me is 36 minus 64, which is an answer of negative 28. So negative 28 here. Now I need to take the square root of both sides. But this too is a problem, because we know that what we're asking is what two numbers could we multiply together that are the exact same and get the answer of a negative 28. Well, that's impossible, because a positive times a positive would be a positive answer, so it couldn't be this. So I couldn't be multiplying two positive numbers together. But a negative times a negative also could not be this, because a negative times a negative is always positive, and this is a negative answer. So that means I'd have to multiply a negative times a positive, which isn't the same as multiplying the same number by itself. So really what I have here is an impossible situation. We can't take the square root of a negative number. And if you ever have this, and let's say you even tried to type it into your calculator, you're going to get out an error. And when you see that, you should think of two things. First, okay, did I mess up my algebra? Because, hey, we've all done it. You guys watched me nearly do it just a second ago. And I know that you've watched me do that a lot more times. But the other thing you should think of is, okay, no, I checked my algebra, it makes sense. Look back at your assumption. Because if you have an error in the logic, and you know that the logic that you use from here on is solid, it means that your foundational assumptions are wrong. So what have we assumed? Well, we've assumed that this and this intersect. If that leads to an impossible situation, then that assumption needs to be false. So that's just like a rule of logic, which, by the way, is pretty great for your own life. If you're finding that no matter what you do, no matter how reasonable you follow a rule, and it always ends in disaster, maybe you should rethink some of your foundational assumptions. But that's a whole nother life thing. Let's look down at number 10. So number 10 is our next question, and I've written out the basics of it here. It's told us that the area of a circle is 100 pi and that it has a center of 3, 0, and we want to know the equation of a circle. Okay, so right away, I'm going to try to get some of my information down. Now, I like to start with pictures and formulas. And right now I have two formulas that pop out. First, area. I know that the area of a circle is equal to pi r squared. And second, equation. I know that the equation of a circle is equal to x minus h squared plus y minus k squared. And and that all equals r squared. Okay. And I know in order to solve this equation, or to get, a formula of a circle, I need to fill in h, I need to fill in k, and I need to fill in r, or r squared. When I look at this, I know I have h and k because the center of my circle is hk. So I'm going to fill in hk here, where h is 3 and k is 0. That means that the only thing I'm missing in my formula is what is r squared? Or what is r? I could do either one. Now I've used this piece of information, maybe I'll use it again, but let's check out my other piece of information first. I know that area is equal to 100 pi, and that the area formula is pi r squared. That means that pi r squared is equal to 100 pi. Well, look at this. If I divide both sides by pi, since they're both multiplying by pi, I'm left with the fact that r squared is equal to 100. Now I can take the square root of both sides and I'd see that r is equal to 10, again ignoring the negative 10 because distance is always positive. But since my formula actually asks for r squared, it's kind of handy just to leave this as r squared equals 100 and have this whole thing equal 100. I can still simplify it, and it wouldn't be wrong also to have a 10 squared here. I just like to see the square itself. And that's going to give me a simplified answer of x minus 3 squared plus, well, y minus 0 is just y squared is equal to 100. And that would be our final answer, and we'd be done with that problem. So that brings us to our final number, number 15. And I think I labeled the last one 10, and it is actually 12. Sorry about that. I'm not going to redo it. So the next one is the town of Cartesia, or whatever we want to call it, has a post office that is the center of the coordinate system, and a local jail that has the coordinates -4, 2. That just means that the jail is 4 miles west and 2 miles north of the central post office. A criminal has escaped from jail and is traveling on foot. It is estimated that the criminal can travel at most 8 miles per hour. So we want to write an equation for part A that shows us the farthest possible locations of the criminal 1 hour after his or her escape. So first thing first is, when I'm thinking about this situation, it's not bad to get a little sketch down. So I've got, let's say this is our post office central, right? We're talking about a coordinate system where the post office is central. I'm just going to draw a little mail there. So the next thing I know is that the local jail is at -4, 2. So if -4, 2, this is the local jail. And we've got some criminals there. I'm just going to do a little house for the jail. Not going to get too creative. You guys know my artistic skills. So what I want to know is, how far could this criminal have gotten? Well, he can travel at 8 miles per hour. And he's had 1 hour to go, which means he could have gone at most 8 miles. So he could go at most 8 miles down this way, 8 miles down this way, 8 miles this way. In fact, all the way around in every single direction. In fact, you might be noticing something. What we are forming here is a circle. And that circle has a radius of 8, because that's the farthest he could have gone. And it has a center at our central coordinate, which we're told is -4, 2. So I know that r equals 8. And I know that hk, or our center of the circle, is -4, 2. And if all I need is the equation of a circle, well, that requires that I fill in this formula, x minus h squared plus y minus k squared. I think this thing will be going through my dreams at this point. It's equal to r squared. So let's fill in these terms. H is -4, so that means that I have x plus 4 here, squared, plus y minus my k value of 2 squared is equal to 8 squared, my radius squared, which is 64. And that would be my final answer. And that's part A. Now, this is actually something that maybe you wouldn't normally see in this way, but this actually does help with search patterns. It tells people to look anywhere within this radius, all of these places within this radius. And it can even be even more helpful when you can get a broader idea of it. So that's what it's doing in part B. It says, what about an inequality that represents possible locations of the criminal T hours after the escape? Well, if you look at this answer, and I'm just going to use what they have written here, I'm just going to explain why this makes sense. Notice we still have the center of the jail at -4, 2. So this is our starting point. And it's saying that for every hour that he escapes, he'll be able to go 8 miles. That means that it's 8 times the amount of time that's passed. So if he's gone, if it's been 2 hours, it'd be 8 times 2, or 16 miles. That's the radius, that expansion that he can go, where it's twice as far out there and the circle's getting huge, right? And in 3 hours, it's going to be 3 times 8, or 16. That's not 16. 3 times 8, 24. Bringing us way out here until it's like not even on this. So for every hour, it gets multiplied by 8. So here we end up with 8t squared being our radius. And you might also notice that they have an inequality. Now, of course, the question asks for an inequality, but we can also see why this would make sense. Because what we're saying is he has to be somewhere inside the circle. So it's going to be something where the points are less than or equal to that maximum distance away. So if we're talking that first hour, he's anywhere within here, all the way up to those outer points. So you'd want the points to be the values that are smaller than that outer boundary. That's why they picked less than or equal to 8t squared. So that's our final one, with a little bit of a messy diagram to help you out. And if you have any questions on the beginning problems that I didn't explain, or questions that follow up with the ones here, or just anything else, let me know, and I will be online from 1 to 2 today, and really most days. So I will see you guys then. Hope you have a great day, and enjoy the new lesson for the day. See ya!